So now that we have our source, let's create our simulation, our first simulation. So we'll create a DOP network. Everything happens in DOPS. Our DOP network, and we'll create it. We'll call it pyro sim. Let's go inside, and we'll need a couple of elements here. First thing we need is a smoke object. This smoke object is going to be the container that's going to hold all the information that we're going to be actually exporting from the simulation and using later on, either for rendering or for generating other effects based on this. But this is the most important container that we have. Now, of course, just as important, we'll need a pyro solver to actually calculate all the motion of the smoke. So we'll connect this to the first input. The other thing we need, of course, is we need a source of smoke. So let's create a volume source. And this is what's going to bring in the information from our source. I'm going to just make sure we hide other objects here. Let's connect this to the source as indicated. Now we'll connect this to the output, and we're pretty much ready to go. What do we need? We need to make sure that our volume source is grabbing our volume source. So we'll go here to the input. It's going to be a SOP. Let's select the SOP source out. So now we have that source. And what is it that we want to source? We have this initialize with a bunch of presets that makes it easier and faster for us to start working. So even though it says source smoke, the preset isn't actually built in. So you need to switch between something and then source smoke, and you will have your preset. Basically what this is saying is it's just doing 3 operations. You can do this manually, of course, just as easily, but this tends to be much faster, of course. So we have one first operation that's going to be grabbing the density volume from the volume source, and it's going to be adding it to the target field density with a scale of 1. Same thing for the temperature. So it's a scalar field. It's coming from the source. It's a temperature. It's called temperature. The target field is also called temperature, and the operation being applied is an add. We also have a vector field being considered, even though we're not actually, we don't have velocity on our volume source, but it is being considered. But you can leave it as is because it's not going to do anything because it's not going to find that information. That's fine. Now the next thing is here on the source object, and I'm going to turn this on again. On the source object, it is very important for us to understand that the source object will have a limited dimension. We're not going to be simulating the smoke all over the 3D space. We're going to be limiting the region of the simulation, and that's going to happen here. If you hit enter, you're going to see the size of the current container for the smoke, and we need to adjust this to make sure that it holds our simulation. Okay, right now it's even smaller than our source, so it's not very useful. Let's go back to the camera. So the first thing is it's going below ground, and we don't really need it. So I'm going to grab the size, copy parameter, paste relative reference, and divide by 2. So it's always above ground. Let's go up. And the other thing is I'm going to adjust the size here maybe to 5. And then 3 and 3. I think this is going to be enough. Maybe we can even pull the camera a bit more to the back. Yeah, this is going to work. And now if you go to frame 1 and you start simulating, you should see something happening. Okay, there it is. Now, here on the smoke object, we have this division size, which again is a way of controlling the quality and the resolution of your simulation. This division size basically just says that each voxel inside this volume grid is going to be of a dimension of 0.2, which is very big. So let's reduce this to 0.05. But keep in mind that this division size should match the resolution controls that we have on our source. So you can copy this parameter and go back to our source, and here on the volume rasterize, let's paste relative references. Okay, and that way these are always matching up. Let's go up, pyro source, and now it's much slower. it also doesn't look that good because we don't have any lighting on the scene, and that tends to make things look very hard to distinguish. So we're going to solve that issue very quickly just by clicking here on the skylight. Click there, and this will automatically add a sunlight and a skylight. And if we switch now here the quality of the viewport visualization, we should have a much better view of the volume, as you can see here. Okay, now let's have a look at our pyro source. What else? Right now, one of the most important things and the most common things that you will use when you're doing pyro simulation is that you right now from the start, the pyro simulation is considering the whole container, and you have an operator called gas resize fluid dynamic, and this is going to be a way of speeding things up, at least in the beginning, when the simulation, everything that's happening is happening really close to the source. So let's connect this here to the pre-solve. What this is going to do is it's going to analyze the container and detect where in the container nothing is happening yet. And it's going to ignore that. It's going to create a temporary smaller container that's going to be growing as our simulation evolves. So, but we should establish a tracking object to make sure that when the simulation is starting, the gas, that resized container is at least the size of your source. So here on the solve path, I'm going to choose the source again. And now if we hit play, as you can see, the container is smaller, and then it expands until it grabs until it fills the whole container. I'm going to stop this. Finally, here on the pyro solver, there's one more thing that we can do to speed things up for our first simulation. Here on the advanced, you can use OpenCL. And if you have a decent graphics card, this is going to speed up your simulations quite a bit. The result is very similar. It's not exactly the same, but it's very similar, but it's going to be just much faster. Now we can increase the quality of our simulation by reducing the division size even further. Let's go 0.025. Now we have more detail. You can also go to our source and just reduce the size here on the attribute noise. Let's maybe bring the element size a bit lower. 0.2. Let's see how this looks. Okay, so we have a good amount of detail here. Might be a bit too fast, the pulse duration, maybe back to 1. Okay, let's give it a try with this one. I'm gonna hide the source, go back to the camera, and see what you got. Okay. Not a very interesting simulation at the moment, but it is our first simulation. Just gonna reduce the length of our timeline, clicking here, making sure it to 120 is gonna be more than enough. Close. And the next thing I'm gonna do is I'm just gonna let this run, and let's do a quick recap. So what we did was we created our first pyro sim. For that, we created a DOP network. Inside the DOP network, we needed to create a smoke object, a pyro solver, and a volume source. The volume source is going to be used to bring in the information from our source, the source that we created. The smoke object is going to be the container that's going to hold the actual information of the simulation, and for that we need to make sure that the size of the smoke object is adjusted to the size of the simulation that we want to perform. And then we need, of course, the pyro solver to do all the calculations. On the pyro solver, we just went to the advanced and turned on the OpenCL to use a graphics card acceleration, the GPU acceleration, to have faster feedback. We also have created a gas resize fluid dynamic, which is going to allow us to have quicker simulation in the beginning, because it is going to dynamically adjust the size of the container to what we have, the information that's happening inside the big container, and it's going to make it faster, and it's going to save us some memory as well. Okay, so on the next lesson, we'll be looking at how we can control the behavior, some basic parameters that allow us to control the behavior of our smoke.